According to the National Electrical Code, specifically Section 240.21 bone, a tap conductor is defined as a conductor that is protected against overcurrent at both its supply and load ends. In the scenario you've described, where you have a primary disconnect feeding a transformer which then feeds a trough, which in turn feeds two secondary disconnects, neither the transformer nor the trough themselves are considered tap conductors according to the NEC definition. The key to understanding why lies in how overcurrent protection is applied in the circuit. The primary disconnect acts as the overcurrent protection device for the primary side of the transformer. The two secondary disconnects act as overcurrent protection for the circuits extending from the trough. Because the transformer itself is only protected on its primary side by the primary disconnect and the trough is only protected by the secondary disconnects that it feeds, they do not meet the requirement of being protected at both ends. Therefore, they cannot be classified as tap conductors. Let's delve further into the specifics of tap rules and how they apply to different electrical installations. The concept of tap conductors is rooted in allowing shorter runs of smaller gauge wire than would normally be permissible according to their ampacity. This exception comes with strict requirements to ensure safety and prevent overcurrent situations that could lead to fires or equipment damage. There are specific rules governing the length of the tap conductor, its ampacity relative to the upstream overcurrent protection device, and how it is terminated. For instance, NEC Section 240.21 outlines various tap rules, each with specific conditions that must be met. These rules often depend on the length of the tap conductor and the type of occupancy served. A common tap rule is the 10-foot tap rule, which allows a tap conductor up to 10 feet long without overcurrent protection at the tap point, provided certain conditions are met. Firstly, the tap conductor's ampacity must be at least 1/10 of the rating of the overcurrent device protecting the feeder or branch circuit. Secondly, the tap conductor must terminate in a single overcurrent device rated not more than the ampacity of the tap conductor. Thirdly, the tap conductor must be installed in a raceway if it leaves the enclosure. Another widely used tap rule is the 25-foot tap rule. It allows for a tap conductor up to 25 feet long under specific circumstances. Firstly, the ampacity of the tap conductor must be at least 1/3 of the rating of the overcurrent device protecting the feeder or branch circuit. Secondly, the tap conductor terminates in a single overcurrent device rated no more than the ampacity of the tap conductor. Thirdly, a tap conductor is protected from physical damage and is installed in a raceway if it leaves the enclosure. It's important to note that these tap rules are exceptions to the general rule that conductors must be protected to their point of supply. These exceptions are permitted under specific conditions to provide flexibility in electrical installations while maintaining safety. When considering a transformer, it's also critical to understand the overcurrent protection requirements for transformers themselves. NEC Section 450.3 outlines these requirements, specifying how transformers must be protected on both the primary and secondary sides. The protection scheme depends on the transformer's size, impedance, and application. Generally, transformers rated over 600 volts must have overcurrent protection on both the primary and secondary sides. For transformers rated 600 volts or less, the requirements vary depending on the transformer's primary current rating. The primary protection is intended to protect the transformer from overloads and internal faults. The secondary protection is intended to protect the secondary conductors and connected loads from overcurrent conditions. Regarding troughs, also known as auxiliary gutters, these are essentially metal enclosures used to house conductors and provide a point for splicing and tapping conductors. Troughs are governed by NEC Article 366. It is important to follow the installation requirements outlined in Article 366 to ensure proper support, conductor fill, and accessibility. When tapping conductors from a trough, the tap rules discussed earlier apply. The tap conductors must comply with the length and ampacity requirements of the applicable tap rule. Additionally, the trough itself must be properly sized to accommodate the conductors and splices according to NEC requirements. The ampacity of conductors in a trough must also be considered. The NEC specifies rules for directing conductors in troughs based on the number of current-carrying conductors in the trough. This directing is necessary to prevent overheating of the conductors due to the close proximity of multiple conductors in a confined space. In your specific scenario, since the transformer and the trough are not protected at both ends, the tap rules outlined in NEC section 240.21 do not apply to them directly. Instead, the overcurrent protection is provided by the primary and secondary disconnects. This configuration is common in many electrical distribution systems where transformers are used to step down voltage for various loads. When designing an electrical system with transformers and troughs, it's important to consider the overall coordination of overcurrent protection devices. This coordination ensures that the overcurrent device closest to the fault will open first, minimizing the impact of the fault on the rest of the system. Short circuit studies are often performed to determine the available fault current at various points in the system and to select appropriate overcurrent protection devices with adequate interrupting ratings. Furthermore, selective coordination can be achieved by using fuses or circuit breakers with time current characteristics that are coordinated to prevent nuisance tripping and to ensure that only the faulted circuit is de-energized. In summary, while the transformer and the trough in your setup are essential components of the electrical distribution system, they are not considered tap conductors as defined by NEC section 240.21. This is because they are not protected at both ends by overcurrent protection devices. The primary disconnect protects the transformer's primary side, and the secondary disconnects protect the circuits extending from the trough, but the transformer and trough themselves lack overcurrent protection at both their supply and load ends.